بسم الله الرحمن الرحيم. In this lecture, we are going to speak about the integration of rational functions by partial fraction. Rational functions that are f of x equal to b of x divided by q of x. Polynomial divided by another polynomial. And we are going to do it by partial fraction. For this type of function, we have different cases. The first case, if the denominator q of x is a product of distinct linear factors. Let's get that we have q of x, the denominator, is a product of distinct. They are different. a1x plus b1, a2x plus b2, up to a sub k x plus b sub k. All of these are distinct or different linear factors. If we have this case, then the rational function r of x divided by q of x can be written as a1 divided by the first factor, a1x plus b1, plus a2, which is another constant different from the first one, or might be the same also in some cases, divided by a2x plus b2, plus up to a sub k divided by a kx plus b sub k. So the rational function will be, or can be written as a sum of different fractions. When we combine them together, we will have the given function. And this constant a1 or capital A1, capital A2, then capital A sub k needs to be found or calculated. To explain this in more detail, let's have some example. Suppose that we need to evaluate this rational function, or integrate the rational function. I have 5 divided by x minus 1 and x plus 4. We can see that x minus 1 and x plus 4 are distinct factors for the denominator. They are not the same. It means the rational function 5 over divided by x minus 1 multiplied by x plus 4 can be written as a divided by x minus 1 plus another constant, let me call it b, divided by x plus 4. That is a over x minus 1 plus b divided by x plus 4. Now I need to find these constants a and b. So do it. Let's multiply this, multiply by x minus 1 and x plus 4, which is this denominator. I have different ways to find it, but let's do it in this way. Let's get rid of the denominators of the in the given equation. We multiply it by x minus 1 and x plus 4. So this x1, x plus 4 will be cancelled with this one. So the left-hand side will be equal to only 5. Equal. Now the first one, x minus 1 will cancel x minus 1 there. So the remainder will be x plus 4. Then it will be a multiplied by x plus 4. Thus, the second fraction will cancel x plus 4 with x plus 4. So the remaining will be x minus 1. That will be b multiplied by x minus 1. Now to find the constants, I will choose different values for x. If we choose x to be 1, which is the 0 of the second factor there, x minus 1. This will remove the second term. Let x equal to 1, so x minus 1 will be 0. Then I will have the left-hand side is equal to 5, equal a times 1 plus 4 plus b multiplied by 0. So this will be cancelled there. I will have 5 equal to 5a, which means a equal to 1. Now to find b, let x equal to minus 4. This is the 0 of the first factor there. Now let x equal to minus 4. Then I will have 5 equal to a multiplied by 0 plus b multiplied by minus 4 minus 1. So this will give me 5 equal to minus 5b, or b equal to minus 1. We divide by minus 5, I will get b equal to minus 1. So the my integration now, which is 5 over x minus 1 and x plus 4 dx can be written as x, or integration of a divided by x minus 1 plus b x minus 4 dx, which is equal to integration of a is equal to 1 over x minus 1, we can divide it into part, plus b is minus 1 divided by x minus 4. Integration of 1 over x minus 1 is equal to absolute value, or ln of absolute value x minus 1, minus integration of 1 over x minus 4 will be then absolute value of x minus 4 plus constancy, because this is indefinite integral. So this is the integration of ln of x minus 1 of 5 over x minus 1 multiplied by x plus 4 equal to ln of x minus 1 minus ln of x minus 4 plus the constancy. Or it can be simplified more to be then x minus 1 over x minus 4 plus constancy. Let's see if we want to combine them together. Another example. Integration of y divided by x plus 4 to y minus 1. This also can be written as integration of a divided by y plus 4 plus b divided by 2y minus 1 dy. Time to find a and b. So we can multiply this fraction y plus 4 and 2y minus 1, which is equal to a over y plus 4 plus b is multiplied by y plus 4 and 2y minus 1. The left hand side will be equal to only y, because these will be cancelled with these two factors. For the first one, I have y plus 4. This will be cancelled with y plus 4. So I will have a multiplied by 2 minus 1 plus b multiplied by 2y minus 1 will be cancelled with 2y minus 1. The remaining will be y plus 4. That is y plus 4. Now if we let or choose x to be minus 4, this will be 0. So I'll have y, so I said x, it is y, not x. Replace y by minus 4, so the left hand side is equal to minus 4 equal to, I have y there, so it is equal to minus 4. So it is minus 4 equal to a multiplied by 2 times minus 4 minus 1. That will be minus 4 equal to minus 9a, or a equal to 4 over 9. So we found a. To find b, 0, 4, this one is 1 over 2. Just find the zero of the factor. Make it equal to 0. So y will be 1 over 2. So I'm going to choose for the second one, let y equal to 1 over 2. If it is 1 over 2, so this will be 0. Then the left-hand side is 1 over 2. We replace y by 1 over 2 equal to this b 1 over 2 plus 4. That will give me 1 over 2 equal to 9 over 2 times b, or b equal to 9. So the integration will be equal a, which is 9 over 2 divided by, it was y plus 4. Nice one. It is 9 divided by y plus 4 plus b, which is 9 divided by 2y minus 1 dy. This will give me 9 over 2 is constant outside. Integration of y plus 4 is equal to ln absolute value of y plus 4 plus 9. This is constant, and integration of 2y minus 1 is equal to ln 2y minus 1 multiplied by 1/2, because this is coefficient there, should be got a different color, that will be divided by 2 plus the constant c, because this is indefinite integral. One more example. With that we have definite integral x minus 4 divided by x squared minus 5x plus 6. For the first step, we need to factor the denominator. This is equal to 0 to 1. X minus 4 divided by, it is x minus 2 and x minus 3 dx. And these are the factors for the denominator. So the integration will be 0 to 1, a divided by x minus 2 plus b divided by x minus 3 dx. So if you multiply the rational function by x minus 2, x minus 3, we will have x minus 4 equal to, a will go with the second denominator and b will go with the first one. I will have a multiplied by x minus 3 plus b times x minus 2. I need to find the constant a and b. I'm going to multiply the fraction function by this denominator. This will simplify the equation. Now, to find a, I will remove x minus 2 by choosing x equal to 2. So this will be 0. Replace x by 2. I will have 2 minus 4 equal to a multiplied by 2 minus 3. That will give you minus 2 equal to minus a, or a equal to 2. Now to find b, I will choose x to equal to 3, the 0 for this one. Now let x equal to 3. This will cancel the first one. Replace x by minus 3, I will have 3 minus 4 equal to b minus 3 minus 2. Or it is not, it is 3, not minus 3. 3 minus 2. So this will give me minus 1 equal to b. So the integration, which is x minus 4 from 0 to 1 divided by x squared minus 5x plus 6 dx equal to the integration of 0 to 1. 1 is equal to, or I equal to 2 divided by, we said x minus 2. We go back to see it. It is x minus 2 there. You have to be careful about the order. Plus b is minus 1 divided by x minus 3. Which is equal to ln of x minus 2 minus ln absolute value of x minus 3 between 0 to 1. Now I need to evaluate this function. So it is 2 multiplied by ln. Replace x by 1. I will have 1 minus 2 minus ln 1 minus 3. Now replace it by 0 minus 2 ln of, let's say, absolute value of 0 minus 2 minus ln absolute value of minus 3 or 0 minus 3. So it is equal to 2. This is 1 minus 2 is equal to 1 inside of, will be ln of 1, and ln of 1 is equal to 0 because you have absolute value. This is 0. So we'll have minus ln of 2 plus 2 ln of 2 minus ln of 3. So I can just write it as in the final step as this is minus ln 2, and 2 ln 2 will give me 2 ln of 2 minus ln of 3. So that's it. This is the value for the given definite integral. And it is not only 1. So this is minus 1 with 2 will give me only 1. It is 1 ln of 2 minus ln of 3. So this is how to evaluate rational integration of rational function by using the rational or partial fraction method. And in this part, we only discuss the first case when we have distinct linear factors for the denominator. If they are not distinct, then we have different way to do it.